So today we are going to continue on this topic further, but before that, there are a few basic questions which I will be asking from all of you. All of you, turn your cameras on in the class. Yes, Shakrika, Gauri, Aleph. Khadija hasn't joined the class today, no? Okay. First of all, you guys tell me, give some examples of electrolytes. Give some examples of electrolytes.
Sir, salt.
Salt solution, good. And
So minerals in blood. In blood.
okay.
Acid and base.
Yeah, acid and base. Okay, they are electrolytes. Okay. Furthermore, electrolytes can be of two types. They can be strong electrolyte and they can be weak electrolyte also, isn't it, guys? If I were
Yes,
to
sir.
take a strong acid, for example, sulfuric acid or hydrochloric acid. Okay, now if I were to take a strong acid, so that will make up a strong electrolyte now, right? Or if I were to take a strong base, for example, like sodium hydroxide, it's a strong base. So that will make up a strong electrolyte. Or potassium hydroxide. These are strong bases now. Like in 7th standard, you guys have studied that there are two kind of acids or two kind of bases. Some acids are strong, some are weak. Some bases are strong, some are weak. Getting it? Like you would have learned about acids, like there are some mineral acids and there are some organic acids. Like for example, hydrochloric acid or sulfuric acid or nitric acid, these are strong acids. So these strong acids will make a strong electrolyte. Or you have some weak acids like acetic acid or lactic acid or malic acid or formic acid or ascorbic acid, that will make a weak electrolyte. Getting it now? So stronger the solution, stronger the material, stronger will be the electrolyte. Okay. Then you have two kind of bases. One is strong, one is weak. For example, sodium hydroxide or potassium hydroxide or lithium hydroxide. These are examples, not lithium hydroxide, by the way. Sodium hydroxide and potassium hydroxide. These are some of the examples of strong bases. So strong bases will be making up a strong electrolyte, isn't it? Right? Then you have weak bases. For example, lithium hydroxide is a weak base. So that will make a weak electrolyte. So that should be clear to all of you. Okay, now? That is one thing. Okay. Furthermore, you guys would be aware of the concept of dry cell also. The dry cell that we use at our use in different appliances, like in toys, in torches, etc. In remote, the remote battery that you see, that is basically a dry cell. You know, they are also working on the concept of electrolysis. A solid electrical conductor through which an electric current will be entering. We have one such example, like a dry cell. Getting at what I'm trying to say?
So can you explain it again?
Yeah, I'm seeing now, like you have this dry cell. Okay. In the dry cell also, if you can look at the setup, if you wait to look at the setup of this dry cell, look at this image over here. And this also a metal rod that you see now, that is passing in the central. You can observe one thing, that there's a electrode in this also. Observe this thing, everyone. There's an electrode passing into this also. Getting it? And there's another electrode in this, that is zinc electrode. So electrolysis is taking place in this dry cell also. Dry cell is basically that cell, no? Like in various appliances, it is used in the torch, it is used in remote, it is used, etc. So you guys observe the important things over here. Does it not have electrode in it? It has, no? Zinc electrode, everyone notice this? Zinc electrode. And you have the carbon electrode in it. It also has the electrolyte in it. This, if you ever happen to open a dry cell now, the black powdery substance present in it, that you see now, it's the electrolyte. Like namely here, it is made up of magnesium oxide, carbon, ammonium chloride, and water. That is the electrolyte. That is the electrolyte. So for what I have been trying to explain is that, although we get to see that we have various types of electrolysis, like this one, the most common one which we have studied. But talking about the application of the electrolysis, as in the previous class we learned about electroplating. There electrolysis takes place. That is one such application of electrolysis. This is also one application of electrolysis, where we get to see that we have a solid electric, we have a dry cell. In this also there are electrodes. Electrodes would be the carbon rod in this, and the zinc electrodes right now. Furthermore, in this we get to see we have electrolyte also. And in this also what will be happening, the ions are produced. The ions will be produced in this, and due to that electrical energy is produced. Also you guys know that in a battery, in a cell, basically chemical energy is converted into electrical energy. And there comes a time when all the chemical reactions would have ended. When chemical reaction stops taking place in a dry cell, then it stops producing any charges, then it is of no use. Getting it, everyone, what I'm trying to say?
Sir, I have a doubt.
Mhm.
Sir, normally in the picture we see that there are two electrodes, and one is a cathode and one is an anode, and both of them have two different charges.
Yes.
Then what about in this cell, sir? Like, it has two electrodes, that's
Yep.
true. But then how do we know which is a cathode and which is an anode?
See, basically that really is not important. Okay, now, like such question will not even be asked in the question. I can go on to explain that. That will require another 10 minutes to explain that. Okay, now, like on what basis it is decided. But since such questions will not be asked in the question, the only question will be asked will be like, what are some applications of electrolysis, or does the dry cell that we use in the remote, does that also work on the concept of electrolysis? Okay, now. So it is sufficient for us to know that much. Okay, now. Okay. So this is a solid electrical conductor. This is a solid electrical conductor. Here, the electric current would be leaving via the terminals. As the chemical reactions will take place in this now, as the chemical reactions will take place, right? So due to chemical reactions, what happens? They break up into charged particles. They break up into ions. And that's how electricity will be produced. Okay, that is one thing. Furthermore, in the previous classes, we have learned about some things, like we did learn about LED right now. Also, I did told you that LED has got two wires coming out of it. If you can see over here, there are two wires or two leads coming out of it. So do tell me which one of them is connected to the positive terminal, the longer lead or the shorter lead? They are
Can you repeat the question?
like in an LED now, in an LED bulb, there are two LEDs. One that is longer, one that is shorter. See that this is a LED bulb. So which one of the two is connected to the positive terminal of the battery? The longer lead or the shorter lead?
The short.
No.
Sir,
Mhm.
yes.
Yeah, go on, Chakrika.
Sir, I was also about to say shorter.
No, actually, it's longer. For those of you who are saying longer, that is correct. The longer lead is always connected to the positive terminal of the battery, while this one is connected to the negative terminal of the battery. Okay, now? So that should be clear. Okay. Also, this is the symbol of the battery or cell. This is how it is denoted now. So which arm is the positive terminal, by the way? This one or this one? The shorter one or the bigger one?
The longer one.
Are you saying the bigger one, the positive terminal?
Yes, sir.
Yes, sir.
Bigger one is the positive, while the shorter one is the negative terminal. Okay. Anyways, continuing further, you guys tell me that on what basis the electrode is decided, whether the electrode will be positive or whether it will be negative. On what basis it is decided?
So like when the electrode is connected to the positive, then it became anode, and if that rod is connected to the negative, it become cathode.
Very good, very good, very good. Okay, now Aleph, you will be telling me anions will be attracted towards which electrode?
Cathode.
Wrong. Chakrika?
Sir, anions, right?
Anions, anions.
Sir, anode.
Anode, no? Okay, everyone remember this. Anions, they are negatively charged, while anode are positively charged. So they will be attracting towards this one. Okay. Furthermore, you guys tell me if I have taken an electrolyte, for example, what acid is this? That is
Hydrochloric acid.
no, it is sulfuric acid. Okay, no? That is sulfuric acid. Okay. So if this was taken as the electrolyte, let us say that in this setup, this is the electrolyte. So it will break into what ions? What will it break into?
So H2 and SO4.
Or we can basically say H plus and SO4 minus. Okay, no, not H2. Just say H plus and SO4 minus. Okay, no? So hydrogen ions and sulfate ions. Okay, then. Furthermore, you guys tell me why electroplating is done. What is the advantage of electroplating? What's the advantage of electroplating? Do we do it unnecessarily or it has some purpose? Yes? It's a simple question, by the way.
It increases the life of a machine.
By preventing it from rusting, right now. So there are certain advantages of electroplating. That's why it is done. For example, in the process of electroplating, the metal over which plating is done, it becomes more durable as it is prevented from rusting. Getting it? That is one thing. Okay. Anyways, continuing further. Let us continue from this. Was this clear to everyone, the process of electroplating, particularly with this example of copper and brass?
Yes,
Yes,
sir.
sir.
Sir, can you go to the
Okay.
previous slide?
This one,
No, sir, before that.
this, or
No, sir, not this one either.
okay, was it this one, or this one? Yes, Chakrika.
Oh, yes, sir, this one. Just a second.
Okay. Good. So electrolysis. One of you please define electrolysis.
Yes, sir.
Okay, Gauri, you go on to define the process of electrolysis. How do we define this? Yes. Okay, anyone else who would like to define the process of electrolysis? Yes, Alif, what about you? We have
Sir,
been
can you
learning
repeat
about
the
this now. What is electrolysis? Define this.
Sir, can you try?
Yeah, sure.
Is it, is it the process of splitting two compounds
Splitting into
two compounds?
into ions actually. Okay, no? Into ions.
Yes, sir.
So basically what we know about electrolysis now, it's kind of an effect in which components of a compound gets splitted into ions due to passing of electrical current through it. Right now, when electrical current passes through the given compound, then it breaks up into the namely positive and negative ions. So that is what electrolysis is. Okay. That is one thing. Okay. So let us continue. Already we have discussed so many things. Talking about this one. In this one, I have some questions from you guys. You guys tell me, why did I choose to make the brass electrode as the anode over here. Why
Sir,
did
can you repeat?
like out of these two electrodes now, why the brass electrode has been chosen as cathode? I mean, actually, why we choose it as cathode? Because it is by convention, no? Like out of the two electrodes, the copper electrode, we choose it as anode because what we learned in the beginning, like one of the electrodes has to be of the same metal of which the electrolyte solution is. Okay, so copper electrode is there and the solution also has copper sulfate in it. The electrolyte chosen here is copper sulfate solution. So one of the electrode is copper. Okay, we have done that. While the second electrode actually needs to be the metal on which we want to coat another metal. One of the electrode needs to be the material on which coating has to be done. Getting it, everyone? On which coating has to be done. Okay. Now think of it logically further. Like upon passing of electricity into the electrolyte solution, the copper sulfate splits into Cu plus and SO4 minus. Okay. Right. Now you guys tell me that now this copper is positive and this copper has to be deposited on another material now. Getting it now? So that material over which it should be deposited, I mean to say this copper, it has to be deposited on the electrode now. We have to deposit it on an electrode basically. Getting it? What I'm trying to say? And that electrode here is brass now, right? The deposition has to be done on the brass. So should the brass be positive or negative in order to attract the copper?
So negative.
Negative, no? That is why the material on which coating has to be done is always made the cathode. Now getting this now, why like what is happening? What is the mechanism of all this? Why we choose certain material to be cathode? Why we haven't chosen copper as the cathode?
Yes, sir.
Understood this one? Because otherwise, if the copper was made as a let us say copper was made as a cathode in this case, let us say copper has been made as cathode. So this copper is already having copper in it. Like this copper electrode is already having copper in it. So why we'll deposit more copper on it? Right now, our objective is to deposit copper on brass, not on the copper electrode. Getting it now? So that is the thing. Okay, let's continue the discussion further. Let us talk about some other applications of electroplating. Some applications of electroplating. Gauri and Aleph, you guys particularly tell me, did you understood what I said moments ago? Why this brass has been chosen as a cathode and not copper?
Can you explain it again?
Yeah. See, there you should have stopped me, no? Like whenever you don't get a topic, just stop me immediately right there. See, let us understand this once again. Chakrika, you got this now? Gauri?
Yes, sir.
No, sir.
No, okay. You should have stopped me, no? Anyways. So upon passing the electricity, the copper sulfate breaks into the positive and negative ions, as you can see over here. Now, our objective is that I have to do the deposition of copper over the brass, right? That's what I have to do. I have to apply a coating of copper on this brass now. So copper must get attracted towards the brass now. It must get attracted toward it now. When will attraction take place? When this brass will be negatively charged. So for that purpose, I connected it to the negative terminal of the battery. Hence, it became negatively charged, which we call as cathode. So cathode is negative charged, while copper ion is positively charged. Positive attracts negative. So thereby, the copper ions will then be attracted towards it, and hence deposition of copper will take place over the brass. Is that clear to you guys particularly now?
Yes, sir.
So,
Got
but
this?
then like that what we call negative ions will attract it to the positive, no?
Yeah, obviously. The another one, that is sulfate, no? The sulfate, as you can see over here, this is being attracted towards the positive electrode, that is the copper electrode. Hmm, Getting it now?
Yes,
That
sir.
is also happening at the same time, but that's not important. The main point of observation is this thing about the copper and the brass. So hope that is clear. Now talking about some other applications of it, like we have certain medical equipments that is made up of nickel. Certain medical equipment is made up of nickel, but it is harmful to the human body. So thereby, in order to avoid it from coming in contact with our body, a coating of platinum is usually applied on the surface of nickel. Getting it, everyone?
So isn't platinum expensive?
Platinum, yeah, of course, it is expensive, right now.
So then wouldn't it be hard to like afford it for every single medical clinic?
Yeah, of course, it is. It would be difficult for every medical clinic to afford it, but scientifically, what we observe that nickel, usually medical equipments, they are made up of nickel, but it is harmful for the human body. If it is in contact with the human body for a longer duration, so it will be harmful. So the better alternative is to have a medical equipment, and coating of the platinum should be done on this. Getting at what I'm trying to say?
So can't they use any other metal?
Yes.
Yeah, we can use now, but you see, it is because of the certain property of platinum it is used. Mm. Also, if like nickel is used now, it is kind of toxic. Like for example, if nickel dust, like if fine particles of nickels were to be inhaled by the person, it can lead to infection in our respiratory tract. In our trachea, it can lead to certain infections. So that's why we don't prefer to use it. Although there are some other metals also, but um, not all the metals would be um, would be going through the process of electrolysis. So I think the most suitable metal that was chosen, that we choose to electroplate over the nickel, is platinum. Okay, no. Otherwise, we would be having some cheaper alternatives. Getting it?
Yes, sir.
That is the thing. Okay, continuing further. Or many cases you guys have seen, like certain people's, when they have a root canal treatment is done, or when they get a tooth replacement. So many people, you would have seen that they would be having a gold plated tooth. Yeah, because gold is very less reactive. It does not react. Okay, na? So that's why you don't like, if gold were to be very reactive, so the women's wouldn't be wearing jewelry made up of gold. Okay, na? So in certain cases now, certain medical equipments, for example, if certain, for example, tooth, if it has to be fitted in the jaw, so certain peoples who can afford it, or out of luxury, or out of show off, they would be having a tooth of gold as well. Furthermore, there are many kitchen equipments also, like the bath taps, or for example, different parts of the cars, they will be covered with chromium. For example, you can see over here. The first application which we learned about in medical equipments, what we learned that, as we learned that nickel is, it is used, but plating of platinum is done. Plating of platinum is done over it. Okay. Furthermore, in the case of kitchen parts of certain kitchen materials, for example, kitchen equipments, there it will be used. In like bath taps also, it will be used. Hmm. Then in the car also, car parts also, like chromium is certain parts of the car would be covered with chromium coating. Although chromium is very expensive, it's a very expensive metal right now. So hence the objects are created with the cheaper metal, and the chromium metal is provided. So you can't, like, rather than using two materials, rather than using two expensive materials, the parts of the basic material over which coating has to be done will be chosen as a cheaper material right now, and then it will be covered with the chromium coating. Getting it? Because it is expensive, so hence the objects that are created, objects main object would be created with a cheaper metal, and then a coating of chromium will be done over this. Also, this is done in order to bring a shining over the objects and prevent them from corrosion, because chromium is less reactive. Getting it, everyone?
Yes,
Yes,
sir.
sir.
So you have used, yes.
Can't we just use directly zinc?
Can't we use directly zinc? See,
Yes.
zinc is not as hard as other metals now. Zinc is less hard as compared to iron or aluminum. Getting at what I'm trying to say? Okay, no?
Yes.
So it is because of the property, like not all the metals have the same property, but alloys of zinc can be used. Alloys of zincs are, they are harder and stronger. You guys understand what are alloys now? Like brass is a alloy, stainless steel, that is a alloy. Getting it? So alloys of zinc can be used. Okay, but it has to, we have to take into consideration the weight of the alloy also. Getting it now? Like if you were to use a very heavy alloy, so the weight of the car or weight of the aeroplane will increase, so thereby it will not be um, effective to use it there. Furthermore, jewelry makers would often be making ornaments of less expensive metals and then provide a coating of gold or silver upon them. So there also electroplating is done now. Getting it now? Use of chromium, there you have to learn about, like certain car parts would be coated with this. In this now, first of all, let me just write some important point on this. We will take a cheap metal, and over the cheap metal, coating of chromium is done. Coating of chromium is done. Why we are not taking an expensive metal? Because chromium is already very expensive. That's why. In order for the cost cutting purpose, it is done. Okay. In jewelry also, electroplating is done, as we have learned. Furthermore, the tin cans that are used for storage of the food now, they are made up of iron, and some coating of tin is done on them. The tin cans that you see, the base material is the iron, and over the iron a coating of tin is done. Because iron is reactive now, it can easily react with the food items and can spoil the food and can lead to food poisoning as well. So thereby a coating of tin will be done. So coating of tin over iron. So there also method of electroplating is used. So tin is actually less reactive than iron. That is why it is used. Okay, no? So it will not spoil the food easily. Furthermore, various parts of bridges, they will be made up of iron, because we know that iron is strong, iron provides strength, but however we know that iron is corrosive in nature, like it gets corroded very easily, I mean to say. So right now, so in order to prevent it getting rusted, a coating of zinc is applied over it, and that method is also called as galvanization. Okay, so we have another use of electroplating, that is galvanization. So hope that much is clear to everyone. Okay, if anyone has any doubts so far, please do let me know.
Sir,
Out of
can you
all-
go on previous slide?
Yeah, sure.
Done, sir.
Done. Okay, so far we have learned about electroplating the metals, like all of them. In all these examples, electroplating is being done.
So,
Yes. Mhm.
so silver is a metal, right?
Yeah, silver is a metal.
So when silver turns black, like you see uh, when we buy silver, it is really shiny and all, but then after some time, it turns black. So when that happens, can we use electro?
Yeah, we can use electrolysis to clean. Okay, no, we can use electrolysis to clean black silver. Okay, like if it has turned black, then electrolysis can be used on this. Huh? Or for example, by just taking some for example, now there's a home solution, homemade solution for this. Just you can take some baking soda and you can take some warm water, make a thick paste of baking soda and warm water, and just brush it, just apply it over the silver, na, and leave it for a few minutes, then rub it, then it will be clean. Okay, na? That is also
Yes.
one of the method. Although electrolysis is also used. Okay, now you will be easily able to clean the silver. Getting it now?
Yes, sir.
So that can also be done. Just
So in large industries, do they use electroplating or electrolysis?
see, electroplating is basically one of the use of electrolysis. Okay, now basically in cleaning process also electrolysis will be used right now. So electrolysis at a large scale, if we have to clean the silver, so then electrolysis can be used. Don't confuse it with electroplating. Electroplating is the method in which a coating of a metal is done over another metal. Okay, so that the concept is based upon electrolysis. Now this concept is based upon electrolysis because splitting of the electrolyte is taking place. Okay, and because of that splitting, we are able to do electroplating. In some cases, we'll be able to purify the metals also, like purification of metal will also be done. Like here, while we'll be going to this topic now, there I will explain how we can clean a rod of impure copper. There we'll be learning about it in detail. Okay, now?
Yes, sir.
Okay. Although you can go for other methods also, like if you happen to have a silver jewelry made out of silver, there are so many other ways of cleaning it. Okay, no? Like for example, you can take some aluminum foil, you can say take some detergent also, you can take some warm water. So with the help of that also we can clean it, or with some toothpaste also it can be cleaned, by the way. Okay, anyways, coming back to the topic, so far we have learned about the application of we have learned about application of chemical effect of electric currents. So in the first place we learned about electroplating of metals. Now we are going to learn about other uses of electroplating. Okay, I mean to say other uses of chemical effect of electric current. Like one of the common use of chemical effect of electric current is extracting metal from their ores. So first of all, you guys tell me, I suppose all of you would be aware with the term ore. ORE. Yes.
Yes, sir.
What is it?
So can you repeat again?
Ore. 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 What are ores?
So like iron ore,
Hmm.
diamond ore, gold ore, like that.
So
Okay.
it's the raw material of the
Mhm.
metal.
Raw
You can think of it in that manner. Basically, ore is kind of a rock. It's a natural rock. Okay, and that will be containing very valuable minerals in it. Okay, now although like if you happen to grab a handful of soil from any place, it will be having different minerals in it. It will be having some amount of iron, copper, zinc, or different kind of minerals can be found in it, but it will be found in very less amount, insignificant amount. Like if I go to my garden, if I were to grab some soil, and if I were to do a lab test done on that sample of soil, interestingly I will find that some amount of iron will be present in it. But will it be significant? It will be an insignificant amount, not of any use. But what we observe, that there will be some rockish material, there will be some rock, or there will be some sediments that will contain a concentrated amount of a given mineral above the normal level, above the typically there will be high amount of a given mineral in a rock, and that kind of rock is called as ore. You guys getting it what I'm trying to say?
Yes, sir.
Yes, sir.
So that is what a metal ore would be, and it would be very hard. It would be usually hard. There are different ores. We have ore of iron, aluminum, etc. Getting it? For example, you have a ore named as bauxite. So bauxite is the ore of aluminum. Okay. Then we have ore of iron also. You have ore of iron also. Like for example, some of the common ores of irons would be like hematite is there, or magnetite is there, or limonite is also there, or this one more. There's a by the name of siderite also. So there are different type of ores of iron also. So one such common of them is hematite. Hematite is the ore of iron. It is one of the ore of iron. All of you understood this so far?
Yes, sir.
So pure metals, they are extracted from their ore. The iron is not found in the pure state in the nature. Na? It has to be extracted from its ore, like hematite or magnetite or siderite or limonite, for example. Or aluminum has to be extracted from the impure state, that is bauxite, that is its ore. Okay. So pure metals are extracted from their metal ores with the process of electrolysis. So let us understand how it is done. Let us understand how it is done. So as electricity will be passed to the metal ores now, let us say that you are having bauxite over here. We have bauxite. Now this bauxite will be in the form of huge pieces of rock, so it has to be broken down. Okay, na? So first of all, it will be broken into some smaller pieces, first of all. So we have some bauxite. Bauxite is the ore of copper, right? Bauxite
Yes,
is the
sir.
ore of copper. Is it right? Bauxite is the ore of copper. Am I saying it correctly or wrong?
Yes, sir.
Where's your attention, guys? Bauxite is the ore of aluminum, no? I said it moments ago. It's written over here as well. Be attentive in the class. Is my voice not coming properly?
Yes,
Is there
sir.
some background noise from my side?
No, sir.
Okay. So what will be happening as we'll be passing electricity through it now? As we pass electricity through the metal ores, they get broken down into into smaller pieces now. Basically, into a form that is like it will be getting broken down into form of ions. Basically, what happens? It gets broken into ions. Okay. Of course, some water and other liquids is also added in this. Okay, no? So as you can see over here, you have a fluid-like substance over here in which aluminum ore is present, that is bauxite is present. And as the electric current is passed through it, it gets broken down into ions, right? Now, it gets separated into two components. It gets separated into two components. One of them is the pure aluminum that you see over here. One of them is the pure aluminum, and the other components would be ionic lattice basically, or you'd be having the aluminum or cryolite over here. So the one that you see right below the alumina or cryolite, that is the pure aluminum metal. Getting it, everyone, what I'm trying to say? That is a pure aluminum metal. And for some other metals also, this process will be done. So this was the process of extraction of aluminum via electroplating. Via electrolysis, I mean to say. So have you guys understood like what is happening here basically? Due to passage of electricity, what happens? Here now, this is basically this whole thing that you see. It was the solution of aluminum oxide. This was the solution of bauxite. Okay. It was the solution of bauxite basically. Upon passing of electricity, what happened? Pure aluminum got separated from it, and it collects at the bottom. It collects at the bottom. Furthermore, you can see over here there's an opening also here. Why this opening? The pure aluminum will start to come out. The pure aluminum will start to come out. Let me just explain it once again. What was the whole thing that is happening here? So what we have done now, we have taken two electrodes over here. As you can see over here, the positive carbon anodes and the negative carbon cathode is there. Two electrodes have been taking place, have been used over here. Okay. Now, as the current is passed into this, what we see that the pure aluminum found in this in solution of bauxite, it will dissolve in this, and then it will slowly settle down in the form of molten state. In the form of liquid state, it will settle down, and slowly via the aluminum, via this outlet, it comes out, and rest all of the impurities will basically remain suspended in this. So that's the process of electrolysis used for extracting the aluminum from its ore. Have you guys understood the basic concept here, like what is basically happening?
Yes, sir.
That was solution of bauxite. That is solution of bauxite. As the current was passed into it, so what we observed that this solution of bauxite and this the pure aluminum, it will settle at the bottom and it will be extracted out, and rest all the impurities will remain suspended in this. So our main concern is with this aluminum only. Water, alumina, and perlite, we don't pay attention to that as of now. So that is one such application. After this, we are going to learn about the purification of metals also, like how purification of metal would be done. Okay. So first of all, you guys tell me that you guys understood about extraction of the metals from their ores or not?
Yes, sir.
Yes, sir.
Okay, no? Although there are various methods of extraction of metals, electrolysis is just one of them. Okay, no? In certain cases, carbon is also used. Getting it, no? Certain cases, carbon is also used. So talking about electrolysis, what we learned, how electrolysis is used, it is basically being used to separate the metal from their ores, right? And this is a very complex solution over here. Also in nature, what we know that metals would be existing in a combined state with lots of other elements. Like this aluminum, Al2O3 now. This is the formula of the bauxite. Like in bauxite, aluminum will be found combined with the oxygen, as you guys can see over here right now. They are chemically combined with each other. So it has to be separated from the oxygen in this. Okay. That is one such application. Now you guys know, like in certain cases, even bacteria's help of bacteria can be taken place. The help of bacteria can also be used to extract certain kind of metals. In certain cases, we can take help of carbon also. Okay. Anyways, you'll be learning about that in geography. Yeah.
So to extract to extract the metals from their ores, basically right now from the bauxite, and we have to extract aluminum, right?
Yeah,
So
we
to
have
do
to
that,
extract aluminum.
can we melt the ore to do that, or do we just directly put the ore into the steel container?
Okay, see. Basically, there are various methods of extraction of aluminum from it, from their ores. One of the method is just this electrolysis method. Okay, no? The one that will be more convenient and more effective, that one is usually preferred. Okay. And although you know that the process of electrolysis now, it is quite expensive because of the amount of electricity that will be used in this. Although whether we can obtain aluminum from bauxite by melting the ore, that's a point of question. We'll have to really look into it. Okay, no? Because too much of temperature would be required. There also, there also like too much of temperature would be required to melt the ore of aluminum. Like you just think about this now. Like if I were to just show you an image of bauxite, then you will get an idea about how rocky and how hard this substance is. So thereby, you guys yourself think like if I were to ask you to melt a rock, will it be very easy for you guys to do so?
No, sir.
No. So it is basically a kind of rock, no? Oh, what happened? So just have a look at this. This is the bauxite ore. So it will be really difficult for us to melt this. So lots of temperature would be required. The temperature needed will be very high. So it will not be economic now. It will not be economic. Hence, electrolysis, I think, is usually preferred over this. Hope it is clear, Chakrika, and to others as well.
Yes, sir.
Okay. Okay. Let's see if we can cover this topic, although we don't have sufficient time. Anyways, so another use of electrolysis is purification of metals. Okay. Also, the revision test is you guys are which you guys are giving now. As I was going through the test paper of Aleph, you have attempted all the questions. You don't have to attempt all the questions. Okay, no, you have to attempt the questions that are being asked only. Okay. Like out of
Okay.
the 20 multiple choice questions, you have to attempt only 11. Okay.
Okay.
Anyways, talking about purification of metals. See, here also electrolysis, the method of electrolysis will be used to purify a metal. Say that there's a thick rod of impure copper and there are lots of impurities in this. Okay. So those impurities now, those impurities, in order to separate this, electrolysis will be used. Let us understand how. The very first thing which has to be done, the material that has to be clean, it will be made anode by connecting it to the positive terminal of the battery. So this is the anode over here, right? And furthermore, you see that the another metal, the another electrode which we have taken, it is the for example here it's copper, right? And this metal this electrode has the same metal as the impure copper has. Both of them have copper in them. Getting it? Both of them have copper in them. So let us discuss this further how this basically happens. As the electricity will be passed into this electrolytic solution, as the electricity will be passed into this, also note down that the electrolyte also has the same metal that has to be purified. Like copper has to be purified. So this electrolyte which we have taken, that also contains copper in it. Getting it, guys? That is copper sulfate. Okay. So the impure metal here has been chosen as a node. So this will start to dissolve in the electrolytic solution. Getting it? What I'm trying to say? As current will be passed into this, the impure metal, it will start to dissolve in the electrolytic solution and then deposit on the cathode in the pure form. That is on this plate of pure copper, the copper from this impure rod starts to deposit. So the impurities, what about the impurities then? The impurities of this impure rod will remain in the electrolytic solution and it will deposit at the bottom. So you guys have understood so far what I'm saying? What basically happens as
Can you
electricity?
explain it again?
Yeah, sure. As the electricity will be passing through it now, so the copper will start to separate out from this, and those copper being positively charged, what we know, it will get attracted towards the cathode now because cathode is negatively charged, right? So those copper ions now deposits over this thin plate of copper pure. So deposition of copper from the impure rod takes place on this pure rod, right? Once all the copper would have deposited on this, right now, all the copper initially after some time it will deposit on this pure copper plate. What about the impurities? The impurities present in this, it will simply dissolve in the electrolytic solution, and then after some time it will settle at the bottom like this. It will settle at the bottom. Usually it will be settling, just 1 minute.